तुम लोग को, इतने अच्छे अच्छे दोस्त हैं मेरे।
Continuing the saga of our numericals, dear students, on board postulate, here we are. Calculate the change in angular momentum. Wait. When I say angular momentum, in my mind what is getting registered is L. Of the electron when it jumped from third orbit to first orbit. Well, first thing. Before I analyze the problem, let me understand the concept. Whenever an electron is rotating in an orbit, it has certain angular momentum. And that angular momentum is different compared to the other orbit. So I can say in these two orbits of third and first, the angular momentum are different. And I have to find the difference. So simple. Why is it different? Because from Bohr's second postulate, I have the formula L is equal to NH upon 2 pi. H upon 2 pi no doubt is constant, but N differs, so will your L. Let's start, ladies and gentlemen. Pen and paper, please. N1 is equal to 1. That is first orbit. N3 is equal to 3. Of course, third orbit. And then to find L3 minus L1. Now, it's an oral sum, to be very honest. But we have to follow certain formalities. So, formula is L is equal to MVR, that is equal to NH upon 2 pi. So, what I will get is solution. And in that solution, from formula, I can say L1 is M1 V1 R1. And M is constant, so I can simply say M. So, or N1 H upon 2 pi. Same is L3, that is N3 H upon 2 pi. When I say subtracting L3 and L1, we get L3 minus L1 is equal to MVR2, or basically this is the base. Second formula is much more, I guess, convenient, right? So I can directly write this as L3 minus L1 is equal to H upon 2 pi. N3 minus N1, that is 3 minus 2, that is equal to 1. Oh, not 1, come on. 2 gets cancelled, that's why we get 1. So H upon pi. H is a numerical constant, the value is 6.63 10 raised to minus 34, and pi is 3.14. Let's start with the anti-logarithms and logarithms. Log of 6.63 minus log of 3.14. Log of 6.63 must be oral now. 0.8215 minus, again this must be oral, 0.4972. Subtract it, you get this answer. Once you get this answer, separate the 10 ka power and anti-log of 0.32, 4 and 3. So once you do this, you get L3 minus L1. That's simple. Write this complete box and that's how you get the answer. Simple, wimple, easy weasy. Following by the next sum, that is energy of electron. When I say energy, what kind of energy they're talking about? Total energy. And when it comes to total energy, I have one formula. En is equal to E1 upon n square. So let's start. Energy of the electron in second Bohr orbit is minus 3.4 electron volt. Okay, E2. Calculate its kinetic energy, potential energy in the third orbit. Second orbit is given, I have to find third orbit. So there is a twist. So let's start with the given part. E1 is given minus 3.4. To find Ke of third, Pe of third. Formula is very simple. Energy is proportional to n square. That is inversely. And K is minus of total energy. And P is twice of total energy. So let's start. We have E3 upon E2 is equal to 2 square upon 3 square. It's an inverse relation. That is equal to 4 upon 9. So from there, we can get E3 is equal to 4 by 9 of E2. And once that is done, E3 will be equal to what? 4 by 9 minus of 3.14 into Y. Come on. E2, the value is already given, 3.4. So E3 will be equal to 4 upon 9, that is equal to 0.444 into minus 3.4. That's more than it. So E3 will be equal to minus 1.51. Simple enough. Now, E3, that is total energy of third orbit, has been known. I want kinetic energy of that orbit. I want potential energy of that orbit. So there's a formula. K is equal to minus of T. Just subtract it. You'll get your answer. Big deal. And about potential energy, it's twice of total energy. I'll just multiply by 2. That's it. 1.5 to 2, almost 3. Potential is 3.02. Now that's the numericals of atoms, molecules and nuclei. But these numericals have to be done orally when it comes to your CET or any other entrance exam. But for your board exam, you must show all these steps. Then only you'll get the answer, and don't expect else. Okay, I'll see you all with more numericals in my next module.